So for all these problems, you'll be choosing one of these four options. We have growth and decay, and in the compounds, whether it's K compounds per year or continuous compounding here. Now, number one, if you read through it, we're going to use growth. And we have the initial amount, 700. 1 plus. Now, what about R? What's going to go in for R? They say 100 pi percent. Well, as a decimal, 100 pi is 314.159 and change. Still percent. So to get rid of the symbol, you move the decimal 2 spaces to the left. So 3.14159. That will go in for R. 3.14159. Now, what about time? Here, time has to agree with R. This R is measured in 2-week intervals because it says every other week. So here, this time has to be measured by 2-week clusters. If you read the problem, they want us to advance 120 hours from now. But the question is, 120 hours equals how many 2-week intervals? So we have to turn 120 hours into 2-week intervals. Well, 2 weeks. How many hours is 2 weeks? Let's see. Let me get rid of some of this. 2 weeks. We know that 2 weeks is 14 days. Every day is 24. So 14 times 24, so 336 hours. So time is measured in blocks of 336 hours. Well, notice we're not even going to advance one block. We're just going to go 120 hours. That's not even one whole jump. So up here, to decide what goes in here, 2-week blocks, we have to take this and divide it by this. So let's see, what's 120 divided by 336? That's about 0.3571428. And this number makes sense because it's smaller than 1. Because time has to be measured in 2-week blocks. We're only going 120 hours. So let's take this decimal and let's plug that up in here. If you want, just keep the fraction. 120 out of 336. And this is 3.14159. If you type all of that into your calculator, it should give you the answer, which was about 1163. 1163 friends on your MySpace page. So this is believable, this answer, because it's growth. It grew from 700 to something more. So for the Dragon Zord, it's going to be, it says decay. The current value is W, and it's going to go down 9%. And here time is measured, it says in the paragraph, as decades. The Megazord, they tell us flat out, it's currently worth 200. And this is going to go up, so addition, by 5%. And time is measured in terms of centuries. They want to know the value of the Megazord at the time when the Dragon Zord is only worth 1% of W. So we want the final value of the Dragon Zord to be 1% of W. So here's what we do. If the Dragon Zord started at W, 1% of W would be literally 0.01 W. And everything else can stay the same. Right? We start at W, and the final amount is 1% of W. These W's cancel. We're left with 1 penny equals 0.91 to the power of t. This equation is in exponential form. Rewrite it into log form, and it'll look like this. Calculator here for this. Calculator for that. Log base 0.91. T here, t is about 48.83 decades. That's decades. Now in the Megazord, we want to plug this time into here, but in the form of centuries. So a century has 10 decades. So take the 48.83 Well, what is it? 48.83 if you want to round it like that. That's decades. If you divide it by 10, it'll be 4.883 centuries. And that's the number that goes in here. And then calculator on all of that, it'll say about $253. The value of the Megazord has gone up. Okay, for number 3, it says that a certain deposit will quintuple. So quintuple implies 5. And R, they say it's 0.7%. So to get rid of this, we go boom, boom. So 0.007. That goes in for R. 0.007 over something to the power of something. Now, here, this number K is how often the money gets compounded per year. Per year, per year. In the word problem, it says that it happens every X hours. But I want it to happen blank times per year. Now, here is the fact. Let me just put a quick fact up here. 1 year is 365 days. But if you go 365 times 24, you get on a calculator 8760 hours. 1 year is a lot of hours because there's a lot of hours in a year. There it is. Now down here, let's say that something happened. Let's say that something happened every 24 hours. Then over here, you'd go 8760 divided by 24, and the calculator would say 365. And I believe that. If something happens every 24 hours, then it happens 365 times per year. Now, what if something happens every X hours? How many times does it happen per year? Well, what did we do when it was 24? We divided it into 8760. That's the same thing we do here. 8760 divided by X. That's how many times this money will compound per year. So this fraction is what goes there and also what goes up here, right in for K. So this goes here and there, and we just have to multiply this by time. But recall that this is in terms of years. In the word problem, they say how much time? They say like 2014139.311 hours, which if you go calculator, and if you divide that by 8760, as we said, this is the same as 229.9245 years. So this is the number that would go up here. So what I want to do now is I want to write down the equation that we're supposed to solve. And let me switch colors. Let's go green. And we can agree to piece cancel. So we have 5 equals 1 plus 0.007 over 8760 over X to the power of 8760 over X times 229.9245. Now here's what I want you to do. I'll put parentheses around the exponent. On Desmos, I want you to type this in. However, instead of equals, I want you to type in a squiggle. And instead of X, feel free to just to change it to like Q or something like that. Because Desmos prefers like not X. It prefers like a random letter like Q or K or W. So type this in here. 5 squiggle. 1 plus this over all of that. Use Q's instead of X's. Parentheses around the X one. And you'll see that Desmos tells you like this, that Q is about 53. Q represented X, which was the goal. We are done. So in a situation like this, I'll let you know on the test, use Desmos to solve weird equations like this. Because to solve this equation by hand with logarithms, it will not work. We use Desmos for a problem like this. So the first person has continuous, 4 pennies. So 4 pennies continuous. Okay, that's that first person. And the other person, it's 60 every 60 hours, and that's 13 pennies. 13 pennies. 1 plus, what's the R? The first person is 5.7. So we know this person here, their R is 0.057. Let's see. And then the other person, every 60 hours. Okay, so we don't know R, but every 60 hours, that's going to be that 8760 divided by 60. Right? That's the discussion we just had with question number 3. If it happens every 60 hours, you divide it into 8760 because that's how many hours there are in 1 year. And the whole fraction represents the number of events per year. What else? It says by the time Anne's account is worth 1 million and change, this person's account is worth something else. State the interest rate. So the goal is R. That's the goal, to find R for Anne with an E. And we know that for the first person, let's go down here, their account is going to be worth 1067814.05 equals 0.04 e to the power of 0.057t. We can easily solve this equation with natural logarithms. First, divide both sides by 0.04. Then use natural log. Do all that. I want you to tell me what time is. So for time, I got 300. And that's the time that we want to use for this person there. And then we can solve for R. And we know what Anne's final amount is going to be. Anne's final amount is supposed to be 1052.43 equals 0.13, 1 plus R over 8760 over 60 to the power of 8760 over 60 times 300. Solve this equation, and it should be the case, as it said on the key, that R is about 3%. How do I solve this equation? Divide by this first, and then turn this into a fraction, use the reciprocal power, then subtract the 1, then multiply both sides by this fraction. So follow those steps, and you should see that R is about 3%. All right, so this is question 5, and the goal is to find the value of H. Let's focus on the left-hand side before anything else. Let's rewrite this as log p to the 1/2 power over log p to the power of 3. Yes, because the square root is just the power of 1/2. This 3 can come up here to serve as the power of p. Now, also recall, let me put that back here. There's the 3. Recall that log base AB could be rewritten as log b divided by log a. I want to use that property right now. This looks like this. Let's rewrite it to make it look like that. Okay? So if I do that property, this fraction would then say log base p cubed p to the 1/2 power. But we could take the 1/2 and move it out to the front. So we'd have 1/2 log p cubed, and then here it's just p. Now, how about I throw a power 3 and then a 1/3? Now let me send the 1/3 to the front to multiply with the 1/2 to turn it into 1/6. Doing that, we're left with log base p cubed of p cubed. And this equals 1, right? Log base p cubed of p cubed, that equals 1. So it disappears. So it's just 1/6. So that's why I did this trick of 3 and then 1/3, because once this was moved to the front with the 1/2 to create 1/6, I'd be left just with p cubed to match p cubed. So basically, this whole original fraction, that just equals 1/6. So let me backtrack all the way to the beginning. Let's just write this as 1/6 equals log base 4096q over log base h cubed. And how about I multiply both sides by log base h cubed? log base HQ. These are gone. So I have just, let's just call this 1/6 log base HQ equals log 4096 Q. And recall, the goal is H. Now, from here, how about we use a fact? There is a fact here. Check out this fact. If you play around with your calculator, 4096 is 4 to the power of 6. That is a fact. What if we look at the right-hand side and rewrite it as log Q over log 4096? That's allowed, right? We can separate it into two separate logs like that. And this equals log Q over log. Now, instead of 4096, let's rewrite this as 4 to the power of 6. And I want to take that 6 and move it down here. So this equals log base Q, or just log Q, over 6 times log 4. And I want you to see that this is equal to that. So maybe what I can do here in green is write down a new equation, the one that says that this is equal to this. So I'd have 1/6 log base HQ equals. Now I want you to see that there's an invisible 1 right there. And I could combine it with the 6 below. They give me 1/6 log Q over log 4. This 1/6 cancels with this 1/6. Now if I take this information there, and if I rewrite this, I could go here, and I could rewrite that as log base 4 of Q equals, and just bring this up there, log base HQ. Look at that equation and conclude and deduce that log Q matches, so the bases must match. That's how we get that H is equal to 4. So very messy, my writing, but hopefully the explanation made sense. So if you have any questions, let me know in the comments below. See you guys tomorrow.